So now you can see the multiplicative form, there are AND gates. Then additive form, there are OR gates. So multiplicative forms are based on the AND gate and additive forms are based on the OR gate. So you should be know that properly. Okay, so next law is identity law. We'll draw the diagram for that also. Okay, so identity law. Now, what is the first law? First law was idempotent. Second one, identity law. 1 multiply with A or whatever input, multiply with 1. What should be the output? It should be A. Why? There is on A. So on is going to multiply with, if on, this is on means 1. So on is going to multiply with, that means AND gate, A. So A might be 0 or 1, no issue. Okay, so A might be 0 or 1. So if 0 multiply with on 1, that is 0. If 0 on multiply with on, that is 1. So the output is depend on here, depend on the A. Why? If A might be 0, so this is 1, 1 multiplied by 0, 0. Why A is 0, therefore 0. 1 multiplied by, think this is 1. 1 multiplied by 1, this is 1. Therefore, the output also working as A. Look at this one. In truth table, we have 1 as input and A as another input. So A consists of two chances, 0 and 1. So 1 into 0, 0. 1 into 1, 1. So the output will be, what's that? It is identical. The output of this one, 1 into A, that is equal to A. So identity law says 1 multiplied by A is equal to what? A. It is equal to A. Then 0 plus A. 0 plus A means if everything is 0 plus A, that also equal to A. Right? 0 plus 0, 0. 0 plus 1, 1. So that is equal to A. The next one, 0 into A. So whatever the value multiplied by 0, that will be 0. 0 into 0, 0, 0 into 1, 0. Next one, 1 plus A. This is obviously 1. Why? A may be 0 or 1. Whatever the value plus with 1, answer should be 1. Okay. So like we can write the identity law. So if you need, I'll draw the logical diagram for this one. You better copy down while I'm drawing. Then if there is one O, assume this is O. If O input A going through the another AND gate, then output will be off. Why? Multiplication is there, therefore, if it is multiplying, the output also 0. That is off. Okay. Then next type, addition. Now that means I am drawing this one 1 and I drew the third one. 1 and 3. The next one, if A, this is 0 and input 1 is A, that is going through OR gate. Okay, so if it is going through the OR gate, output will be A plus 0, that will be A. Next one, 1 going through A, addition, 1 plus A, whatever value is containing A, output will be A. Sorry, output will be 1. Input is 1, therefore output should be 1. So this is second one. And this is the law name is identity law. This fourth. Do you know why am I drawing these circuit diagrams? At the end, you should be simplify any gate with the help of universal gate. To simplify those, you should know all the rules what we are using there. Okay, quickly copy down this. So additive forms are the OR gate one. Okay, so this is additive form. This also additive form. That means we are using OR gate. That is addition. Okay. Then next one we are going to take the multiplicative form. This one and this. Then we are going to use the multiplication. Okay, so those are the two types what we are going to handle, multiplicative form and the additive form. Okay, so this one also we had additive form and multiplicative form. So now we are moving to the third type. So third type is inverse, or else we call complement law. Inverse law or else complement law. Now look at A multiply with A bar. Okay, so A is 0, 1. A bar means 1, 0. So if these two are multiplied, 0 into 1, 0. 1 into 0, 0. So two opposite. If the opposite are multiplied, then output will be 0. Additive form, A 0, 1, A bar 1, 0. If these two add, we will get the addition. Okay, so when we use inverse as a law, so A into A bar equals 0. Why? There is a 0 in at least one side. Then the other one, A plus A bar is equal to 1. Why? One side will contain 1. Therefore, the addition will be 1. Okay, logically, you have to think that. Okay, so you better start completing. Then by the time I draw the diagram. So normally no need to draw the diagram, but you should get the clear idea of this. So if there is a input going on, and if I use the NOT gate, then that will be A bar. Okay, if this A bar and this A, I can use the same input, okay, because I need the A only. So if these two are going through the AND gate, then we will get the output A dot A bar. That means what? Output is equal to 0. Why? Opposite is there for the multiplication. Then exact output will be 0. The next one. If I have A, then A bar then A is going through this one. And if it is going through OR gate, we call it as 1. Why? If A is 0, then A bar should be 1. Therefore, one side should be 1. So if A is 1, A bar should be 0. At least one input should be 1. Therefore, output will be 1. Okay, quickly copy down both. So we call this uh, this one as multiplicative form because the multiplication and gate is there. Then other one we call as additive form because addition is there. Okay, additive form, and this is multiplicative form. Okay, quickly draw the diagram also. And the truth table, logical expression. So we call this one as implement law, or another name, complement law. Complement means the opposite one is there. That's why. Okay, copy down this. Okay, fourth law is the very important law, De Morgan's law. Okay, now look at mathematician named De Morgan's developed a pair of multiple laws regarding group complement in Boolean algebra. Okay, I'll tell a small story, then you will able to understand. Okay, so now I'll take the same value which were there, A dot B. Okay, now imagine there is A and dot B. Normally I'm taking bar as, just imagine this is the bar. So think there is a rocket going on top of the A and B. Okay. So when the rocket moves on the sky, you can see the cloud. So like now when the rocket is moving, what is happening? Clouds are breaking on the sky like small lines. Okay. So rocket is going on top of what? Dot. So dot is there. Dot mean multiplication. If the rocket move on the top of the dot, that means if there is a bar on top of the dot multiplication, the bar is going to divide into two parts. Then this bar, while dividing that into two parts, dot becoming plus. Okay. The bar is there, the rocket is there. If the rocket move in top of the dot, that rocket is going to break into two. That means bar is going to break into two pieces. Then dot is going to become plus. The answer will be like that. Again, same story I'm going to take. A plus B. Okay, so I said, now there are A plus B. There is a rocket is going on top of the A plus B. When the rocket moves on top of the plus sign, plus is moving to the dot. When the rocket moves on the sky, it makes some clouds. Likewise, then that clouds are breaking, or a rocket is going to break into two parts, and plus becoming dot. Then I'm going to put the same thing values there. Okay, that's it. De Morgan's law says if there is A dot B and over bar on top of the dot, then over bar is going to break into two and give that bar for these two. A bar plus dot becoming plus B, then B bar. A dot B over bar, then De Morgan's law. When we apply the De Morgan's law, when we apply De Morgan's law, the A dot B bar is divided into two bars. A bar plus B bar will be there. If A plus B over bar means that we both are applied this bar, A plus B over bar, then over bar is going to break into two. That means A bar dot B bar. Can you understand? So now we'll see what is happening. So if we are using A dot B dot mean multiplicative form, so if there is multiplicative form and over bar is there, then dot multiplicative becoming plus A bar plus B bar. Then A plus B over bar is there. Then the plus is there. So plus means additive form. So if the additive form, that means it is going to become multiplication A bar dot B bar. Can you understand the process? Okay. So we'll move to the truth table. So multiplicative form A dot B over bar. This over bar is there for both the side. Okay. So A dot B over bar is equal to A bar plus B bar. Just look at the story which I said. If the rocket going to on top of the multiplication, then the rocket breaks into two, or else cloud is going to break into two. So A bar plus B bar. So same way, A bar plus B bar. Then we move to the additive form, A plus B over bar. So then we will get what's happening there. A plus B over bar. So A bar dot B bar. Okay. So here we will get A bar plus this one. A bar plus B over bar equal to A bar dot B bar. So we call it as additive form. Why? Additive form means the question starting from this scenario. So addition is there. And the multiplicative form means when starting, we have the multiplication with a dot sign. Okay. So shall we now look at A, B. So obviously you know the truth table. 0, 0, 0, 1, 1, 0, 1, 1. I told you this first one 0, 1, 2, 3. Decimal order is there. So A dot B multiply A dot B 0. 0 into 0, 0. 0 into 1, 0. 1 into 0, 0. 1 into 1, 1. So then A dot B over bar we need. A dot B over bar mean opposite of this one. Then 1, 1, 1, 0. Then we are going to take A bar. A bar means 0, 0, 1, 1. 1, 1, 0, 0. B bar means 0 na 1. 1 na 0. Then 0, 1, 1, 0. Then what we are going to add these two. A bar plus B bar. You will get 1 plus 1, 1. 1 plus 0, 0. 1. 1. 0 plus 1, 1. 0 plus 0, 0. Okay, so here when you are adding, we are not going to take any carry bit. 1 plus 1, 1. That means on plus on. On mean on my. So here this one, A, B, normal process 0, 0, 0, 1, 1, 0, 1, 1. A plus B, addition of this one. 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1. A plus B bar. That means opposite of this column. 0, therefore 1, 1 means 0, 1 means 0, 1 means 0. Then A bar, the opposite of the column A. 0, 0 means 1, 1. Then 1, 1 means 0, 0. Then this column B bar, 0 na 1, 1 na 0. Then 0 means 1, 1 means 0. The final one, we are going to multiply A bar column and B bar column. When both the columns are multiplied, you will get 1 into 1, 1, 1 into 0, 0, 0 into 1, 0, 0 into 0, 0. So finally, these two columns are, just look at both the columns. These columns are identical. And these two columns also identical. So highlighted columns are identical. Okay. By the time I draw the circuit, you better copy the logic gates. I think this also better to keep there. You better write this one also, the method how we simplify. Write it clearly. Okay. Then I'll draw the diagram. A dot B. Input A, input B, both are going through multiplication and bar. That means what? Multiplication is there, A dot B. So the bar means NAND gate. So it is equal to A bar plus B bar.